Alright, so I told you to pay attention to the number of bacteria. Alright, so it says graph the number of bacteria versus time in seconds. Begin by counting the number of bacteria present at each second and plotting the appropriate points on the set of axes below. Consider how you might handle estimating these counts as the population of the bacteria grows. Alright, so go back and look at that video again. And it happened very quickly. So you need to really concentrate. Go back and look at that video and create a table. That's the best thing for you to do, is create a table that will show you how many bacteria you have. Alright, so we're going to look at this, and I'm going to create this table over here. And we're going to have our time in seconds, and we're going to have our number of bacteria. Alright, now at 0 seconds, before I did absolutely anything in this video, before I pushed play, you will notice that there were 2 bacteria there. I want you to go back and look at the video at 1 second, 2 seconds, and 3 seconds. And see if you can count the number of bacteria that you're going to see there. At 1 second, you're going to notice that the number of bacteria doubled. It became 4. Then you're going to notice at 2 seconds there were 8. At 3 seconds there were 16. The 4-second mark gets a little tricky. Alright, as well as the 5-second mark, because it's multiplying so quickly that it becomes very difficult to count. So this is where we have to create or come up with an estimate, or come up with something that we might be able to see. So if I'm looking at my table and I'm seeing what's happening here, then I might be able to decide what do I think is going to happen at the 4-second mark. What do I think is going to happen at the 5-second mark? Alright, so look at this, guys. What's happening to my numbers? 2, 4, 8, 16. They're doubling. So can I estimate what I think is going to happen at the 4-second mark, the 5-second mark, even going on to 10 seconds? Could I possibly estimate the number of bacteria there? Alright, so let's go ahead and let's look at our graph. So I've got my time in seconds. I'm going to label this over here our number of bacteria. Okay. And I'm going to, let's see here. We'll label it. It's kind of difficult to label this because my numbers are going to get really big. But maybe we could label it, let's go by 30s. Well, let's go by 15s. 15, 30, 45, 60, 90, 120, 150. Okay. Let's label it this way. Now, at 0, there's 2 bacteria. So, guys, it's going to be really, really, really close to that 0. all right? At 1 second, I had 4. It's not going to change much, okay? It's not going to change much. At 2 seconds, I had 8. Once again, I'm not going to see a lot of change. 3 seconds, I had 16, which is going to get a little bit bigger here. So then let's think about this. So what do we think is going to happen at the 4-second mark, at the 5-second mark, at the 6-second mark? Well, if we are estimating that they are doubling, and that's what's happening here, then I can say, okay, well, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, so 16 plus 16 is 32. So at 4 seconds, I'm thinking that I'm going to get about 32 bacteria. So then I say, okay, 32 plus 32 is 64. So at 5 seconds, I'm thinking it's going to be about 64 bacteria. All right? And then 64 plus 64 gives us 128. So at 6 seconds, I have gone to over 128. All right, so here's my graph. Now, it may not be exactly accurate because once again, our numbers, it's kind of hard to tell according to that video. But by the best that we can do, what we can see with the information we have, we can see that it looks like it's doubling each second. All right, so will the curve ever be perfectly vertical? You guys remember vertical? Straight up and down. So here I've got my curve, and my question is, will it ever be perfectly vertical? Think about that. It should never be perfectly vertical because my time is always moving. So 7, I'm always going to keep moving to the right of my graph. All right? It will never be perfectly vertical. All right. So the narrator, and I didn't give you the voice on this because I wanted you to concentrate just on what it was looking like. The narrator says that 1 bacterium divides every 20 minutes. All right, so if 1 bacterium divides once every 20 minutes, how much real time has passed what we watched in the time-lapse video? Now, we did time-lapse video, we did it in seconds. What you need to understand is it did not take 6 seconds for this to get 128 bacteria. The first division to get 4 bacteria was actually 20 minutes. All right? So that means in order to get the 8 bacteria, it would be 40 minutes. So what we're going to do is, now what they want us to do is they want us to use real time. They want us to graph the number of bacteria in real time. Okay? Real time. What's it going to look like in real time? So let's create a new chart. And I'm going to do this one a little bit differently because we need to add 3 columns here. We're going to have our time, our original time, which was in seconds, if you remember. We're going to have our new time, which is in minutes. And now we're going to have the number of bacteria. I'm going to extend it just a little bit because we've already figured out some of these other times here. All right, so going back, our original time was 0 seconds, and there were 2 bacteria. We started with 2 bacteria, it's still 0 minutes, okay? Nothing has changed. All right, then I'm going to go ahead and fill this part in. I need one more row here because I want to fill in my 6, okay? Because I'm still looking at my original times. The number of bacteria never changes. The only thing that's going to change is my number or my new time. All right, so I told you that the narrator actually says it takes 20 minutes for the division to happen, for the bacterium to divide. All right, so if I'm making one division, 20 minutes has passed. If I'm looking at the second division, how many minutes have passed? 40. Third division, we're adding 20 more minutes on there because 20 minutes are going past every time we're making a division. So now we've got 80 minutes. All right, now we're at 100 minutes. Now we're at 120 minutes. Okay, so now I have the information that I need in order to create a chart or to create a graph in real time. Okay? So using this table, I want you to take a minute and I want you to sketch a graph of what this is going to look like. They've already labeled our time for us. All right? Now we just have to label our number of bacterium. What's going to happen to the number of bacterium? It's going to become huge. It's going to become huge. They have actually gone all the way up to 300 minutes. All right? We'll look at that in just a moment. But let's think about this for a second. You take 128 and add 128 to it. That's going to give you what? 256. Then you take 256 and add 256. That's going to give you what? 516 or 512. Then you're at 512 plus 512 is 1,024. All right, and then you've got 1,024 and 1,024, which is going to give you 2,048. Notice how our numbers are getting quite big. When you're doing your chart here, or your graph here, we may need bigger numbers. We may not be able to start and just count by 2s or count by 5s or count by 10s. We actually may need to count by something way bigger. You know, it's kind of up to you how you want to look at it, and it's kind of depending on how we, how far we want to go with this graph. I'm going to count by thousands. So I started with 1,000 and then I just started skipping by 2s, all right, because I didn't have enough room to label my whole entire. Guys, what you got to understand is these numbers, like 10,000 may not even get us where we need to be, depending, like I said, on how far we go. Alright, so we're graphing in 20 minutes. I'm sorry, at 0 we have 2. 20 minutes we have 4. 40 minutes we have 8. 60 minutes we have 16. And look what's happening. Our graph is really not moving a whole lot. Our first several points are going to be bunched right there together because we haven't reached a huge amount just yet. So we're just kind of gliding along this x-axis here to give us our points. And we're not going to start, like I said, we get 140 minutes would give us 256. So we're not going to start seeing anything. So 140 minutes is 256. 160 minutes would be 512. So now I'm going to start getting up there a little bit more. 180 minutes would give us 1024. So now notice what's happening. Now I'm starting to move my way up. I'm moving my way up that graph. But it took us to almost 180 minutes to start showing some sort of curve. Alright? So then 200 minutes would give us 2048. Alright, so now we're moving up here. And 220 minutes would give us 4,096, almost 5,000. Alright, so 240 would give us 8,192. And then, like I said, you're going to see that I can't even put the rest of mine on there because I'm going to have over 16,000 in the next 20 minutes. But you can now see that my graph is going to start taking that turn. And now my number of bacteria is getting there. Okay? Alright. Now what they want us to do is we're no longer looking at minutes, they want us to look at hours. Okay? They want us to redraw this in hours. Now, we need to look, and I don't like the way they did this, because 1 hour, if I'm looking at my chart, I'm dealing with every 20 minutes. Well, I don't get to my first full hour until the 4th set of data, division 3. My 3 seconds is 60 minutes, which is my first full hour. So I need to somehow plot my 0, my 1 second, my 2 seconds, before I can plot my full hour. Then I've got my 4 seconds, which is 80 minutes, my 5 seconds, which is 100 minutes. So I have these divisions in between here. So what we have to do is we have to think about where this is going to go. Once again, I'm going to do thousands. And we already know that this isn't going to give us exactly what we need, but number of bacteria. And then I'm going to go back to my data here. At 0 minutes, there were 2 bacteria. So 0 minutes, 2 bacteria. At 20 minutes, there were 4 bacteria. So think about this. I can divide an hour into 3 20-minute segments. 20 minutes, 40 minutes, 60 minutes. So I kind of have to divide this hour into 3. So at 20 minutes, and my dots are going to kind of look like they're all going to be smushed together. All right, at 40 minutes, I've got 8 bacteria. At 1 hour, I have 16 bacteria. Once again, guys, notice my dots aren't moving. All right, so now I've got 80, 100. At 2 hours, I'm at 128 bacteria. All right, so then I've got 256, and then I've got 512. At 3 hours, I am now starting to get above that 1,000. All right. Then I got a little over 2,000. Then I've got a little over 4,000. And then at hour number 4, I got 8,192. Look at your graph. It is very, very similar to every graph that we have done with this data. If we look at these 3 graphs, they all have the basic same shape. Okay? The basic same shape. They start here and curve up. Start here and curve up. The only thing different is the way my graph is. Like here, I didn't have the same count. But had I had the same count, it would have been really squished. Okay? Or I'm sorry, it would have been really open. This one was more open. This one's squished. So as I change that time, I'm squishing my graph in. All right? So now let's talk about this for just a second. These graphs are examples of exponential functions. So if you want to know what an exponential function looks like on a graph, it's going to look something very similar to the 3 graphs we just did. Okay? So, let's talk about this for just a second. We have talked about linear functions. We have talked about quadratic functions. And today we added exponential functions. Really quick review about the 3 types of functions. What do we know about a linear function? It looks like what when we graph it? Linear functions are straight lines. Okay? Going back to what we learned about quadratic functions. If you remember, let me pull this back out really quickly. A quadratic function is a mirror, all right? It's that mirrored look. So we have a quadratic function. If I were to put it on a graph, it would look something like this, okay? Exponential functions look like this. Guys, you're going to have to know this. You're going to have to be able to recognize the difference between those three types of graphs.